So today I'm talking with Tuomas Riski, CEO of Norsepower Limited, a Helsinki-based company that is developing and installing rotor sails. Tuomas has also been a member of the International Windship Association Executive Committee for the past 6 years. Tuomas, welcome to the IWSA Weekly Interview Series, and please kick things off with your Norsepower presentation.
Okay, thank you, Gavin. So let's start with an introduction to Norsepower. We start with a brief video showcasing our technology on board different ships.
Norsepower is the pioneering frontrunner of auxiliary wind propulsion for large cargo and passenger ships. 2 giant 30-meter rotor sails were fitted on board the Maersk Pelican product tanker in 2018.
On the Maersk Pelican Flatner rotor project, after the installation in August 2018, completed tests with positive results. We had no restrictions on our tradability. We have had no safety incidents. We've had savings on average of 8.2% in the test period.
If Norsepower rotor sails were implemented widely within the global fleet, the annual CO2 emissions of global shipping could be reduced by up to 80 megatons per year. Norsepower's rotor sail technology is a proven and economical solution to help shipping achieve its ambitious emission reduction targets.
So that was an introductory video to Norsepower's technology, showcasing some of the ships where we have already installed our rotor sails. I start with an introduction to Magnus effect and how a rotor sail works. If somebody has played ball games, you might have actually proven that the rotor sail works. We can demonstrate it. We drop a basketball from a high place in 2 different ways. First, we just release the ball, and of course it falls down pretty straight. But if we repeat the same drop so that we make a spin in the ball, have a look. We make a spin in the ball, observe how it's flying, and as you can see, it's not falling straight down anymore. It's flying away from the dam in this case. So anybody who has played golf, ping pong, soccer or tennis has actually demonstrated that the rotor sail is working. And here's an explanation how the Magnus effect works. So that falling ball is in the middle of this slide. Air was calm on the video, but when the ball is falling down, pulled down by the gravity, it's actually facing airflow, which is pointing upwards. And when we make a spin in the ball is spinning and it's rotating a thin layer of air around the spinning ball. And now when this rotating spin air is interfacing with the wind, it's creating the so-called Magnus effect. On this slide, on the right-hand side of the rotating ball, the spin air is opposing the flow of wind. Flows are meeting, overall flow is getting slower and pressure is increasing on the right-hand side. On the left-hand side, the spin air is accelerating the flow, creating a low pressure area. Now this is very easy. High pressure on the right side, low pressure on the left side, causing thrust force, which was curving the path of the ball. So this is how ball games work. And now we make a mechanical sail. On the right-hand side, we can see a rotor sail. It's a straight cylinder with an electric motor inside. So we spend a small amount of electricity to rotate the cylinder. And when we rotate the cylinder, it's also rotating air around the cylinder, just like with the rotating ball. And when this rotating air cylinder is exposed to wind, it's creating pressure difference between the sides of the cylinder. So when we place this rotating cylinder on the deck of a ship, it's becoming a mechanical sail. It's causing forward thrust. When we optimize the rotational direction and RPM of the cylinder, we can make this a mechanical sail, which is pushing a ship forward, reducing main engine load, fuel consumption, and all related emissions. This is an old innovation. Mr. Flatner and Savonius invented this already 100 years ago. What we have done is that we have modernized this technology, introducing modern composite materials and automation systems to make it a push-button mechanical sail for large ships. And this is our current design, our product. It's a rotor sail. It's based on an internal steel tower, kind of mast, through which we are pushing the ship forward, and around that internal steel mast, we are rotating a composite part, lightweight structure, which is the rotating part of our rotor sail. That's how it works. Let's have a look at our references so far. First ship ever fitted with Norsepower rotor sails was Estraden by a company called Bure. We have only positive experiences of this technology on board. We didn't occupy any cargo space, positive operator experiences, and according to independent verification companies, average annual net savings are roughly 6%, meaning about 400 tons of fuel saving per year, giving a payback period of 3 years with MGO price of $650 per ton. So this was our first reference, fitted already in 2014 and 2015 with these two small rotor sails. Next ship fitted with Norsepower rotor sails was cruise ferry Viking Grace. The installation took place in 2018, and this reference case has been investigated by 3 different external verification parties, ABB, NAPA, and Chalmers University. And according to their studies, the long-term annual fuel savings are between 230 and 320 tons of LNG fuel per year, equaling roughly average propulsion power around 250 kilowatts, and also CO2 emissions reduction up to 900 tons per year. This is giving roughly 4-year payback period with a typical LNG price of $600 per ton. Then the third one, we fitted the LR2 oil products tanker Maersk Pelican with our rotor sail, fitted 2 30-meter giant rotor sails as a retrofit in the end of August 2018. Lloyd's Register has collected data from the ship and verified average annual fuel savings of 8.2% during the 1-year actual trial period. And when looking at this ship, typically tankers are sailing close to the equator in quite weak wind conditions, but we can see based on the results that if this ship would be sailing on the, for example, windy Northern Atlantic, up to 20% average fuel saving should be possible. This is a quote by Tommy Thomassen, CTO of Maersk Tankers, so they really see that wind technology has a great potential to achieve their emissions reduction targets, and they are looking forward to fit more of this technology on board. So average savings of roughly 8%, payback period for installation like this is between 4 and 9 years, depending on fuel and routes used by the tanker. Our fourth installation, which took place earlier this year, was Scandline's hybrid ferry Copenhagen. We fitted 1 30-meter rotor sail on board this ferry, and the target of the project is to reduce the emissions on the typical route between Germany and Denmark between 4 and 5%. And our next new released project is together with Norwegian Sea Cargo. They are the first ones to fit rotor sails on tilting foundations. So when they need to pass under a bridge with the ship, they can tilt down the rotor sails with hydraulic hinges. 2 35-meter rotor sails, largest Flettner rotors ever built in this world. Target is to complete the delivery during 4th quarter of 2020. And based on the forecast and simulations, we can see that in the North Sea conditions, we should be able to reduce the fuel consumption by up to 25% with this kind of installation. Summary, our mission at Norsepower is to reduce the environmental impact of shipping, and we do it by providing our mechanical rotor sails. We are today the market leader with mechanical sails for large ships. Our vision is to set the standard in bringing sails back to ocean transportation and to really empower shipping to reach 0 carbon emissions. We can't do it alone, but our rotor sails can be a great help to achieving this goal. I end with the flashback. This is really summarizing what we are doing. We are comparing Stockholm in 1926 and 2018. So in 1926, Mr. Flettner visited Stockholm with his rotor ship Buckau. It was almost 100 years. The next rotor ship to arrive in Stockholm was Viking Grace. She arrived there with Norsepower rotor sail on 13th of April 2018. Thank you. This was our short presentation today of Norsepower concept.
Thank you, Thomas. That gives us a really good overview of Norsepower, the technology, how the rotor sails basically work. And I love that last slide of that of history with the future, not just the present, but the future as well. Now to kind of continue the discussion, I'm wondering, you talked a little bit about your vision. How do you see rotor sails and wind propulsion, in a wider sense, fitting into the industry's decarbonisation, which is pretty much the defining issue that we have for the coming decade?
I think shipping is one of the hardest industries to decarbonize. For long-haul shipping, you always need to have a fuel on board to make the voyage happen. And it's extremely expensive to develop kind of biofuels or non-fossil fuels enabling that voyage. So it's evident that you have to take all measures which are possible to reduce the basic energy consumption of the ship. And we can see, based on our proven results, that in typical cases we can reduce the nominal energy consumption between 5 and 20% with mechanical sails, like our rotor sails. So it's evident that sails are coming back to the market. That's what we are doing, bringing sailing back to shipping. That will happen when we want to decarbonize shipping.
Yeah, so that sort of hybrid approach of having wind propulsion plus fuels, other operational or vessel changes. That certainly I think is a direction or a pathway to decarbonisation that we need to be embracing. What's quite interesting, and I get asked quite a few times, is why rotor sails? Why is the Flettner rotor the technology that seems to be breaking into doesn't seem to be breaking into the market? It is breaking into the market, and it's the first real multiple uptake of technology, wind propulsion technology that we have. Why is that, in your opinion?
As we all know, shipping is a very conservative market. Everybody's worried what kind of harm new technologies can make. And in 2012, when founding Norsepower, it became evident to me that this technology has kind of safety and automation properties which make it such that it can be accepted by the shipping companies. And when we combine this robust and safe technology, with safety I mean that if you just unplug the electricity of a rotor sail, then it stops, then it doesn't make you any harm. So when you combine this kind of robust and safe and fully automated push button design with the fact that the Flettner rotor has biggest produced thrust per area unit of the sail, you can see that it's kind of no-brainer that this should be the technology which can be the first one to enter on the market. And I think this has now happened.
Right. Yeah. Using that word robust, robust. I think those two are pretty much the catchwords of the industry. So that's really interesting. You mentioned about automation. Could you just expand on that a little bit?
Yeah. So as I mentioned during my presentation, in a Flettner rotor, you just need to optimize two items. One is the direction of rotation, and another one is the RPM of the device. So we have been able to develop a software which is just measuring the environmental conditions on board, I mean wind and other things, and the status of the ship, how she is moving. And based on those, we have developed a software which is fully automizing the rotor sail unit. Of course, it can be stopped from the bridge, or you can reduce the power of the rotor sails. But in typical conditions, it's fully automated. It's just giving for the ship all possible forward thrust, which can be gained in the current condition.
And am I right in thinking that you can also monitor the performance of the rotors from a distance?
Yeah, that's correct. So the crew sees on board all the time what's happening with the device, what it's producing, and if there are any issues with it. And we also have a remote maintenance connection to all of our devices all the time. So we can also monitor our technology from our office, and we can maintain them kind of online or assist the crew whenever needed.
Oh, right. Okay. So that gives another layer of sort of protection, or another layer of de-risking a new technology being put onto.
It's correct. And when selling our first installation to shipping company Bure, really what I did in the beginning was just assuring them that nothing bad can happen. So when customer sees that, hey, I'm not risking my ship or my cargo, and there is an upside which I can gain through the fuel savings, then you can make it a deal. These are the two boxes you have to tick to make it happen.
Right. No, fantastic. Yeah, that's great. Now, taking this to another step and bringing it into a sort of market development aspect, where do you see, or what opportunities do you see in the market for wind propulsion, and of course, specifically for rotor sails, but what kind of growth, what kind of size of market are you forecasting?
We have estimated that of the current fleet of 60,000 medium to very large ships, roughly 30,000 could be fitted with rotor sails. And it seems to me that there can be technologies later on which could be fitted on board that remaining 30,000 ships. So I think that it looks like feasible that wind propulsion products can be fitted on board any type of ship in long term. And that's our vision to tackle that market. We are targeting 200 installations by 2025. And based on the current IMO and European Commission targets, it should be feasible to make this wind propulsion market, let's say, size of roughly 3,000 installation by 2030. I think that would be a nice kickstart for the industry. Yeah, but that's happening. We are selling new installations all the time, and we have already plenty of references, and I think there's nice interest on the market. So these are the goals.
Right. No, interesting. And the with the rotor sail development, a couple of things are always interesting to me. I mean, the perception of wind propulsion has been changing as far as I can see. With as more references and more examples of rotor sails are for installation, are you finding that the barriers are starting to reduce around the perception of wind propulsion with the customers that you're talking with?
Yes, I really see it like that. I think our kind of breakthrough project was the one with Maersk, when we were able to prove 1 year ago that we reached 8% average savings with that tanker project. I think that was the main point in wind propulsion so far. Nowadays, I think wind propulsion companies have references on board almost all ship types. So it's been proven that mechanical sails can be fitted on board almost any type of ship. Of course, rotor sails are not, for example, suitable for container ships today. Our technology can be fitted on board tankers, bulk carriers, ro-ros and ropaxes and ferries. Those are the main ship types.
Right. So potentially container ships in new build status could have rotor sail options incorporated into the design, but the existing ones.
You could perhaps have like individual units, but typically the deck is stacked with containers. So if you would fit the rotor sails, it might be that you should remove the container space, and then that's not an environmental investment anymore. You want to minimize the emissions per cargo unit, or how?
Yeah, absolutely. And sort of expanding on that barrier issue. I always found, especially in the early years of International Windship Association, perception was that really difficult barrier to overcome. Other barriers, obviously, I don't want to take words out of your mouth, but obviously fuel price is going to be a critical, and we're in a period of very low fuel prices at present, although other barriers, which ones do you see are major barriers or continued inconveniences for the development of it?
I think in our case, the remaining barrier, it's actually the payback period, as you mentioned. So it's a combination of fuel prices, carbon prices, and some kind of regulation like the EEDI, which really make the market happen. all of these together make a payback period for the end customer, and that defines what's the demand for the products. Our current target is to develop the product and lower the prices so that there would be less than 4-year payback period in average global wind conditions for our rotor sales. And based on today's forecast of the regulation, fuel prices and carbon prices and our expected price development, it looks like that's feasible within some years from today.
So a combination of increased regulation or adjusted regulation. We've got quite a big discussion going on in IMO at the moment around speed limits, around power restrictions, or EEOI or an EEXI. Which of those do you actually see as being the sort of the key policy driver?
I see that carbon price is really now entering into the market. So I think that some kind of market-based mechanism for carbon, like emissions trading, which would set the price of CO2 ton high enough, that would be the real enabler for this market. That would really enable decarbonization of shipping in a market-based way.
No, that's fair enough. Yeah, absolutely. And I'm going to take one of the. I had one of the questions in sort of quick fire round that we're going to do in a moment, but I'm going to bring it in here. You mentioned about ROIs. Is it possible to actually lease the rotors from Norsepower? That would obviously help to change what is a capex and ROI issue into a far more OPEX aspect, where owners can actually forecast how much that's going to cost over a period of operation. So please.
That's possible. We have existing financing partners and some term sheets available to enable leasing of our technology. So we are actually all the time making alternative offers to end customers based on leasing arrangement. Let's see how the market is developing. Of course, it's a question of pricing of money for us or for the end customer, which defines who should buy and own the devices and pay the interest fees and so on. But I think that's an interesting concept, and as said, we are in there. We are offering our rotor sales as leasing already all the time.
No, that's really good to hear, because I think from a macro point of view, I think that leasing, or that shift from heavy capex to OPEX, is certainly one way to unlock the market, especially in that sort of post-launch pad. As we're standardizing the kit that's available, as economies of scale are coming in, with a leasing option there as well, I think we can really unlock the door. So really great to hear that Norsepower is offering that. Now, I have a number of quick fire questions, and we're going to finish the interview with these. And I'd like to remind you, just please keep your answers on these to maybe a little bit more than a yes no response, but no more than a sentence on each one. So some of these questions are ones that I get asked a lot. Others have actually been given to me by other people. First one, how did you get into this field personally?
I wanted to found a clean tech company which technology can reduce the global carbon emissions substantially. I happened to meet some people from the maritime industry who had this idea, and that's how it started.
Oh, great. You've actually answered this one already, but I'm going to ask it again. How many installations will there be of rotor sales by 2030, in your opinion?
Our target is to have 200 installations by 2025, and I hope that the entire market will have in minimum 3,000 installations by 2030.
That's clear. What is the key fuel price level that make ROIs work for your customers usually? I know that's a little bit of a how long is the piece of string, how big is the rotor, just as an overview.
Really targeting combination of fuel price and carbon price. But when you reflect that combination as a fuel price, I see that $500 per ton of fuel, combined fuel price and carbon, should make this a pretty large market already.
Okay, that's good. Hopefully we're on the way to having a fuel cost around that, which we did actually. We were around that price just before the COVID changes as well. Fourth one, do you have any expansion plans that you can share with us?
Today, our existing production is running in Europe, in Poland. We are currently opening another production hub in China, close to Shanghai. So this is our current expansion. Starting from next year, we can deliver rotor cells from both European and Asian production hubs.
Right, which leads me to my next question. If I ordered a mid-sized rotor, your standard mid-sized rotor today, when could I expect to have that delivered? And that not just delivered, but for that to be operational.
If you want to install it in Europe, you can today get it in roughly 6 months. If you want to install it in Asia, you can get it in roughly 8 months. Okay,
and from next year with your new production line in China, would that equal up that 6-month delivery time?
That's what we are targeting.
Fantastic. Okay, this is an interesting one. What are some of the less commonly focused on benefit of your rotor? Can you give us something that maybe we're not expecting there?
Yeah, in several cases, for example, with rotor ships, we have increased the stability of the ship. So reduced trolling, which also protects cargo. So maybe that's one of the effects which are not mentioned so often.
Okay, great. Can other companies actually license to manufacture your rotors?
We have no technical obstacles for that kind of licensing, but it's not being considered with our current business model.
Okay, that's great. I've got 2 more questions. Have you calculated the carbon footprint of your rotor system?
Yes, we have made a full carbon footprint analysis of the entire production and logistics, and in typical cases, the kind of carbon footprint payback of our products, it's less than 3 months.
Right, okay, that's fantastic. And my final question is one that with the growth of the sector at the moment, I'm getting an increased number of people contacting me, asking me, is Norsepower hiring? Are you hiring?
Yes, we are hiring all the time. This year we have hired 3 new employees, and the target is to hire 3 to 5 more next year.
Oh, okay, great. So expansion plans are out there. I'm going to give you the opportunity to give us a 1-minute sum up comment, if you would like, to wrap up this segment. So if you'd like to just summarize where Norsepower is, what Norsepower is doing, and any comments for the future.
So this is a growth stage company already. We are the market leader in mechanical sales in the wind propulsion. I see that we need to decarbonize also the sector of shipping. It's very hard task to be done. It will increase the fuel cost substantially in shipping. And based on that, it's evident that we have to capture all renewable energy which is available on board. And in the old times, ships were only moved by the wind. So it's logical that with modern mechanical sails, we can replace between 5 to 20% of carbon-based energy with mechanical sails and reduce the fuel consumption and the emissions of shipping like that. So that's what we are doing, bringing sailing back to shipping.
Fantastic. Well, thank you very much for your time today, Tuomas. I know you're a very busy man, and I think even for me that you've highlighted some issues there that have clarified what Norsepower is doing, and also those insights into where the wind propulsion market is actually going. Really fascinating. Thank you very much. If you have any questions after this presentation and interview, I'm sure that Thomas will be delighted to answer any that come directly to Norsepower. And of course, if you'd like to send anything about the wider wind propulsion sector, you can also contact me at secretary@windship.org. I'd like to say thank you for all of the listeners' time, and stay safe and fair winds to all. Thank you.
Yeah, thanks. Bye-bye.